Welcome back, everyone. In this lesson, we're going to examine a case where environmental pollution severely impacted the land and land detoxification had to be used to return the environment to a healthy state. The Sydney tar ponds, located in Sydney, Nova Scotia. The tar ponds of the surrounding area were among Canada's most notorious environmental disasters, with the site being dubbed the largest toxic waste site in North America. The contamination posed significant risks to the environment and residents. In this lesson, we'll examine the contamination of the Sydney tar ponds and then the impacts of pollution. Finally, we'll outline the cleanup process used to restore the area. Let's get cracking. First, let's look at the contamination at the Sydney tar ponds. Contamination resulted from a century of steelmaking and coke production in the area. And no, we don't mean Coca-Cola. Coke is a type of fuel with a high carbon content. The steelmaking process involves the reduction of iron ore to produce pure iron, which is then converted to steel. Producing pure iron through reduction requires a lot of fuel, and so lots of coke was used. As we know, burning fuel with a high carbon content can pollute the atmosphere and contribute to greenhouse gases, but there were many other impacts on the environment and the people in the area. So next, let's take a look at the impacts of the pollution. The location of the Sydney tar ponds meant that pollution posed a potential risk to multiple ecosystems. The most significant risk was to the harbour and groundwater reserves. Due to the steelmaking process, the surrounding water was found to be filled with a toxic sludge of heavy metals and polycyclic aromatic hydrocarbons, also known as PAHs, which are known carcinogens, meaning they can cause cancer in humans. PAHs are a group of over 100 chemicals formed during the incomplete burning of coal, oil, gas, or other organic substances. The waste seeped into the groundwater and nearby Sydney Harbour, contaminating these water sources. With the water quality significantly reduced, it became unsafe for consumption and impacted the aquatic life. Marine animals such as fish and shellfish with a toxic amount of PAHs in their system can experience disruptions to breeding habits and sometimes even death. Unsurprisingly, the health of the workers at the steelmaking plants was significantly impacted. Research into their health found that they were inhaling chemicals that were similar to smoking 30-plus packs of cigarettes a day. Residents in the area experienced cancer diagnoses at a rate of 45% higher than the Nova Scotia average. So clearly, there was a lot of pollution in the area. The steelmaking company operated in the area for over a century, from the late 1800s until the closure of the facilities in 2001. So, the area was subject to 100 years of pollution and dumping of toxic waste. How can we reverse that amount of damage? Well, in 2004, the Canadian government announced a cleanup plan for the tar ponds and the surrounding area. This cleanup project would cost more than $400 million. The original plan was to remove the most heavily contaminated material from the tar ponds, all 1 million tons, by pumping the sediment from the area, but to no avail. This process was only 5% as efficient as initially predicted. Basically, the sediment was too thick and dense to pump out. They also quickly realized it would take significant time and energy to physically remediate that much material. So, the organizers abandoned this plan. Then, after over 900 public meetings on the matter, multiple scientific studies and many project proposals, a solution was finally agreed upon. First, solidification and stabilization, a form of chemical remediation, then bioremediation, and finally, physical remediation. Let's take a look. The first step of the solution was solidification and stabilization. During solidification, the contaminated material is mixed with water and cement to immobilize the pollutants and prevent them from spreading, essentially freezing them into the cement. Over time, the mixture dries out and hardens into a solid block. That's why it's called solidification. At the same time, the polluted material becomes more stable through stabilization. While the contaminated material is mixed, there's a chemical reaction between the heavy metals in the polluted material and the high pH level of the cement, which causes the pollutants to become insoluble, meaning they won't dissolve in water and leach back into the surrounding environment. Basically, the contaminated material is trapped in place by solidification and can't escape because of stabilization. Solidification and stabilization made a huge difference, but couldn't reverse all the damage. The second step was bioremediation, a process that uses microorganisms to break down hazardous substances into less toxic or non-toxic substances. At the Sydney tar ponds, this process treated any remaining soils in the area contaminated with PAHs. The microorganisms used in the process were naturally occurring bacteria that could metabolize the PAHs. Essentially, they could eat the pollutants, converting them into less harmful substances like carbon dioxide and water. Finally, the treated material was covered with a layer of clay, clean soil, and vegetation to stabilize the site further and seal it off to prevent any remaining pollutants from being exposed. These layers continue to serve as a physical barrier to prevent contaminants from reaching the surface. Thanks to these remediation methods, the site has since been transformed into a green space known as Open Hearth Park. The space is now home to sports fields, a playground, and even a concert venue. What a transformation! That's all of it. Let's summarize the key takeaways from this lesson. How was the contaminated land at the Sydney tar ponds restored? Solidification and stabilization were used to immobilize the contaminants on site. This is a form of chemical remediation, where a chemical reaction between cement and the contaminated material freezes the pollutants in place. Bioremediation treated any remaining contaminated soil on the site. This process uses microorganisms to break down hazardous substances into less toxic or non-toxic substances. Finally, the entire site was sealed with clay, soil, and other materials, and the vegetation planted further stabilized the area. See you next time!